Hello everybody and welcome to the fourth episode in the AorbTech Pandas series. Today we're going to be taking a look at CSV files. In this episode we're going to be looking at reading a CSV file, editing a CSV file, learning about their properties, and then we're going to be taking a look at a bunch of parameters and functions which you can see I've listed here. So let's get into it. And let's start as always by importing pandas. So let's create a code block here. Import pandas and let's run it, and there we go. Now we've got pandas. Let's start off with reading a CSV file. This is pretty simple. We're going to assign a variable. We'll call it students. I'm going to say it's equal to pandas.readCSV, and inside the brackets here we're going to put a set of quotation marks, and you can put in the entire directory of the file that you want to open. It has to be a CSV file. Or we can, if we're in the current directory, we can put // which means the current directory, datasets, and this is the folder in which we have our datasets in the GitHub repository, which is accessible to you from our website if you prefer. And we're going to use /students.csv. Then what this is going to do is it's going to return our data set, and what we're going to do is we're going to print it to see what we get. So we have 12 elements here, and we have 4 columns, and each row has an index, which is not in the CSV file. This is a property that Pandas assigns to each of these rows, so just keep that in mind. Now that we have this data set loaded in, or the CSV file loaded in, what we can do is look at its properties. So let's go through each of these one by one. First, let's check what the type is. And as you can see, it's actually being stored as a data frame. And we can actually convert from a data frame to a CSV file using Pandas as well. But let's first look at these other properties here. We'll use students dot columns, and let's see what we get. So we get here a list with all of our different columns: first name, surname, sex, date of birth, and that's all. And as you can see, that's exactly the same as we have in here. Now let's look at info. And that just gives us a little information of how the variable is being stored in the computer. It's useful if you're trying to debug some stuff, if you want to know a little bit more information about how it's being stored. Then we can check its shape. As you can see, 12 by 4. 12 is the number of rows we have, although indexing starts at 0, so it says 11. 4 being the number of columns that we have, as stated earlier. All the columns we can see here as well. Finally, we're going to look at the size. We get 48. So these can be used to tell you a little bit about your data set, about your CSV file, the elements contained within, the rows, the columns, and even how it's being stored in your computer. Now we're going to take a look at editing a CSV file, starting with the parameters. Starting with nRows. What nRows does is it allows us to define how many rows from the CSV file we want to use. So how many of them we're going to pull in. Let's create a code block real quick. And let's create a new variable. We'll call it books. It's going to be equal to pandas.readCSV. Then we're going to put in file location, /, so current directory. Then we want datasets /, and we want good reads datasets.csv. And once again, all of these datasets are available on the GitHub. So there are a couple of them we're going to be using in this episode, and then you can check them out and play around with them on your own. They are toy datasets, so they only have around 10 to 12 rows inside each, so not much data to play around with, but it is a good introductory dataset or set of datasets. So let's take a look at these CSV files, see what's inside. Let's run this code, or at least let's print it first. Let's print books and enter. So you'll notice there is one column here that didn't have enough space to render, so it renders here. This isn't a separate part of the data. There's no extra data being rendered here. For your convenience, the indices are still printed on the left, so you can compare them with those found here. So just know that if it looks a little strange, if it looks odd like this, and if there's a slash here, that usually just means that the data that couldn't fit inside has just been put down here. So don't panic if you don't see one of your columns showing up, because especially if you have a lot of data, it won't show up. It'll show up a bit below. So as you can see here, we have a number of books with names, authors, and average ratings, and the number of ratings. And this is from the Goodreads website. We're going to create another code block here. And what we're going to do is we're going to read it again. So, and let's say books5, books_5 is a new variable we're going to create, because we're only going to take the top 5 rows. So that's indices 0 to 4. Again, we start indexing from 0. And we're going to use pandas dot read CSV once again. We're going to put in the name, so we can just take it here, or the directory. And here's where we're going to make the change. We're going to insert a comma, and we're going to add an argument here. So the argument that we're going to add, n rows equal to 5. Then we can print books_5. That's our variable that we created. And what we should see is that we have the same data set, the same ranks, same numbers, except that we're only going to get the first 5 entries, the first 5 rows. So let's print it. We'll run the code and see what we get. Exactly what we bargained for. A slight difference being that since there's less data, we actually did have enough space to fit in the no ratings area. And that's not because we have less data, that's because the entries which took up more space, as you can see, so at position 6 and 7, immediately after 5, were not included. So we have a little bit more space, as you can see, a little bit less than for this one, to fit in all of these entries, and that's why that's happened. Taking a look at use calls or use columns, essentially what it does is quite similar to n rows, except that instead of selecting the rows, we're going to be specifying which columns we want to use. So let's once again use our books CSV, our books data set. So, and just to simplify it, we'll use n rows as well. So we'll say we'll take the top 3 so we don't take up too much space. Then we're going to use pandas dot read CSV. Then we're going to put in the directory, and we're going to say n rows equals 3. That's just the number of rows we're going to be using, so we're going to truncate it to these 3 just so it doesn't take too much space. And now let's specify the columns we want to use. So this is the important part here. Use calls. We're going to say, first of all, we need to put in a pair of brackets there. And let's say we don't want to know the rank. We don't want to know the author or the number of ratings. All we want to know is the name and the average rating. So that's, we can put in name here and AVG underscore rating, so average rating. Then we're going to print books 3. There we go. And as you can see, we don't have the rank, we don't have the author or the number of ratings, we just have the name and the average rating. We can copy this code and we can change this here to use the indices instead. So the rank would be 0, name would be 1, so we can input 1 there. Author would be 2, and average rating would be 3. And we should get the same thing, so let's print it. There we go, the name and the average rating. So there are two different ways of using this method, and that's exactly how. So let's move on to the next. Skip rows allows us to indicate which rows we don't want to include in our dataset. Let's start by importing a dataset. So let's call it films. It's equal to pandas.read CSV. We'll put in the directory, so current directory. Then we want datasets, and we want to put in imdb.csv, once again available in the description, so by our GitHub or website. Then print it. Once again, do not be alarmed if some of your columns get moved to this lower section here. But how do we fix that? How do we fix this happening? How can we include some more columns? Well, very clearly there are some films here which have very long titles, so they're hogging quite a lot of space. So we can see that Lord of the Rings, all of the Lord of the Rings films, no hate against them, are taking up too much space. So what we can do is we can remove them by using the skip rows. So let's, once again, let's say short name films. That'll be our new variable, so only the films with the short names. We can also remove the good, the bad, the ugly, just to be a little fair. Pandas.read CSV. Then, in this case, this is very important, indexing starts from 1. This can be kind of confusing. First, let's just get this directory in here, and then you'll see what I'm talking about. So, comma, we'll put in skip rows, equal to, put in our brackets. Now, indexing starts from 1, so that means we don't start from here, 0. We actually start, funny enough, from 1. Pay attention, do not pay attention to rank because it could change. These are just the columns in our CSV file. Instead, just add 1 to the index here, right? So we want to remove 5, 7, and 11, and also 9, right? So what we actually want to remove is 6, 8, 10, and 12. So let's go in here and input 6, 8, 10, and 12. Then let's just print it. Print our variable, that is, short name films, and hopefully we should have some more columns show up in the top section. Let's run that code. There we go. Only one column was excluded, and that was no ratings. We can actually do better than that. As you can see, the film with the next longest name is the Shawshank Redemption. So even though it's in the first position, we will have to remove it just to see if we can try and fit everything in, just for fun. So let's run that, and we still didn't get it. Okay, let's remove The Godfather Part 2. Okay, that's in position number 4, so we'll just add that in here. I really want to see this column on the right. Okay, there we go. Still no. Okay, I would keep trying, but it seems that no matter how long I go at it, I do not think I can get this column to show up here. So I think it's a good demonstration though of how this works. You can remove any one of these rows that you want. Of course, all of the data will remain the same. As you can see, the indexes that this creates, it creates a new set of indices ranging from 0 to 5 in this case, since we removed this many films. And as you can see, it doesn't change the rank. So the rank is no longer 1, 2, 3, 4. It skips over all the movies that we removed, all the films that we removed. Let's take a look at index_col, or index column. Let's create a code block here, and I'm going to try and explain this while doing it because it's going to make a little more sense that way. So we're going to say movies underscore ranked is equal to pandas dot read CSV. Put in our file directory. Pandas. There we go, pandas. Then we're going to put index col equal to, and I'm going to put 0, and I'll try and explain why now, okay? So print movies ranked. So when we created these variables here and we printed them out, as you can see, we have all the columns here and all the rows and everything, all our data, but we also have these indices on the left side here, right? That's the index column, right? What index col allows us to do, or index column, is it allows us to set one of these columns as the index itself, which is pretty cool. So I could, for example, index these movies not by an arbitrary number that we give them, but by their rank, for example, which could be pretty useful, right? Because if you want to get a movie based on its rank, these will not always line up with the actual rank of the movie. So, or these indices, right? So we can do something like this. Now, you should only use this when you know that each element of every row of this particular column is going to be unique. So that means no repeating values, because indices need to be unique. You need to be able to access something via its index. So it needs to have a one-to-one relation with that element, right? So index col in this case, we're going to want to use the first column, right? So that's this one here. So let's print it and see what we get. Oh, there we go. Let's run that code. So now, as you can see, the index, there's no more column on the left with all the indices. Rank is our index column now. So we can actually access these values based on their rank. So that's pretty cool, right? That seems a lot more intuitive than using some arbitrary number. And this is especially useful when you have something like this. So these indices are not, it's not easy to tell which movie you're going to get from the index, right? Because this one is already a rank above, right? So you'd expect 0 to at least have the first one, right? But it doesn't. Then you'd expect, okay, 2 to 3, that makes sense. Okay, 3 to 4, no, because we're going to 5, right? So there's some discrepancies here. It's not a perfect relationship. But when we set this as the index, we can access them in a more intuitive way, which sometimes is what you want. It's something that makes more sense, right? So that's why this is quite useful. Let's head on to the next part here. So what does header do? Well, it's kind of unintuitive, but I'll try and explain it best I can. Let's create a code block and really quickly print our films variable so we can see it again. Now, what is a header? Well, this thing up here, that is essentially the descriptions of each of the columns. So rank, name, director, length, average rating, number of ratings, etc. Whatever it might be for your data set. That is basically the heading. Now, we can change that with a little piece of code called header. So when we're defining our variable, let's say we want films 1 is equal to pandas.read CSV, put in our directory, so the usual. Now comes the weird bit. Header equals, let's say none. Let's say we want to remove the header. What's going to happen? So let's of course also print it. There we go. And it seems at first that it has worked. We've removed the headers. They've been replaced by their indices. But if you look just one row below, you'll see that the header has actually been moved down to the 0th row. So if we want to really remove the header, what we can do is we can use one of the previous parameters, which was skip rows. So we can skip rows and we can skip the 0th row, okay? Let's see what we get. So now we have an actual headerless data set here, or data frame. And as you can see, the ranks remain the same. So it's a little unintuitive, and you think, okay, that's a little strange. But let's say we want to make one of these entries here the header. We can actually do that. It is also a little unintuitive, but again, I'll explain everything. So let's copy this code here. And what we can do is we can change it to, let's say, the third entry or the fourth entry, 12 angry men. We want 12 angry men to be at the top, right? So 12 angry men is at the fourth position in terms of its index. Let's put that in and see what happens when we print films 1, or perhaps let's make it films 2 now. So as you can see, 12 angry men is not the header, it's the first entry. Which you'd think, okay, that's weird, that's very strange, because now The Godfather Part 2 is the first entry. But if we go back, this is exactly what happened here, right? With our headers going down to the 0th entry. So what we can do is we can skip rows once more at the first position. We'll get 12 angry men as the header of this data frame, which is just, I mean, peculiar, very strange. So it's a little unintuitive, and it takes some getting used to. If we want to rename the column headers for our data sets, all we need to do is use the names parameter. First, let's take a look at a new data set which has some purposefully long names that we want to shorten. We'll call it menu. That's the variable. We'll read the CSV, put in a directory, so /current directory. Then we want to access data sets / menu items.csv. Once again, available in the description via our website or in GitHub. Let's print it. That's what it looks like. And cost to produce and cost to customer are very long column names. So let's rename them. We'll just copy this code. Bring it over here. Let's change this to short menu. We'll add in a comma, and we'll use in the names parameter, put in our brackets. We'll keep name the same because it's already quite short. We're going to change cost to produce to cost, and we'll change cost to customer to sale price or sell price. There we go. And we'll keep category the same. Now if we print short menu, we got names, not name. You'll see that while we do get the header with the shorter names, you must remember that it moves them down the original headers to the 0th index. How do we get around this? We use our good friend skip rows. We'll skip the first row, and there you go. Now, we need to check if we didn't accidentally skip anything important, right? So, of course, we have the names here, but let's check the first entry, which is at the 0th position, cheeseburger, price of 1.25, category of food, which is there. How about fries? It seems to also be in the original, chicken nuggets, and I think we get the point. So, as you can see, all of the data is still there. And that's how you change the name. Let's take a look at dtype. What it does is it allows us to change the data type of one of the columns in our dataset. So let's take a look at a new dataset once again. Let's call the variable employees. We'll use pandas.read CSV, put in the directory. Now let's print it, see what we're working with. Don't forget the CSV at the end. And as you can see, we have all of these pieces of data here. Now, salary is currently being stored as an integer value, but salaries are not always a perfect round number, so we might want to store them as a float, for example. How do we change this? Let's copy the code here. Say employees is equal to pandas.readCSV, the directory, and then we're going to input dtype equals, we're going to use a dictionary here, and we're going to have key value pairs such that the value on the left, or the key, is the name of the column, so salary, and the value on the right is the new data type that we want to cast to. So in this case, it's int, so let's change it to float. Then let's print employees, see what we get. As you can see now, each of these has a decimal point at the end of it. Now let's take a look at the functions, starting with head. So what this does is it shows us the first n rows of the data set. So let's take a look at our employees data set real quick. Now let's say we want just the first n rows. So I'm going to print employees.head. By default, this is going to give us the first 5. There we go. Let's say we want to print the first 3. We can also have that. Let's say we want just the first. We can have that too. Now, let's try tail. What tail does is the exact opposite. It gets the last n, or by default 5 elements. So let's use our students data set from before. And let's get the last 5 students. So as you can see, we get 1, 2, 3, 4, 5, right? Remember that the index is not the exact number. It starts from 0, so this would have been the 12th student. Now let's say we want just the last 7 or the last 3. So we can do both of those. Copy this over. And let's do this with perhaps menu items or short menu from before. So we can get the last 3 items here. And that's the end of this episode exploring CSV files. Quite a lot of information, but I think we got through it just fine. If you enjoyed this episode, please make sure to like, subscribe, and share, and hit that bell icon if you want to see more videos like this from us. Make sure to check out our other series as well on this channel, such as our Pandas series and our NumPy series, and the other series that we're working on related to data science. If you would like to see the source code, it is available in the description. There is a GitHub link, and there is also a link to our website with the other GitHubs and all the other coding projects that we have. So make sure to check those out if you'd like to practice. Have a lovely day, and we'll see you in the next episode. Bye-bye.